Hello, friends. Welcome back to geometry class. Hope everybody is doing well and you're able to keep up with the work that we're doing. Today, we are going to further our knowledge about circles and using area and circumference. So we're still using that. We're going to start off with this do now. So we've got a circle here, and I see I've got two lines that are parallel lines, and then I've got two arcs on the circle marked with their degrees. I would like for you to find what is the value of this arc right here. B, find the value of that arc. Pause the video if you need to. Make sure that you've got your notebook ready, pencil, calculator, all of the tools that you need ready to go. And when you've solved the problem, then you will unpause the video and I'm going to go on to the solution. So what we know is because we have these two parallel lines right here, that means that we have two congruent arcs. So this arc right here is the same measure as this arc labeled B. So all together from a whole entire circle, it adds to be 360 degrees. So what I did was I set up an equation, B plus 96 plus 168 equals 360. And when you solve for that, you end up with B is 48 degrees. We're going to jump right into our examples, our problems today. And so one of the things that you need to remember is that the formula for area of a circle is pi r squared. And remember that the radius is the distance from the center of the circle to the outer edge. The diameter goes through the center all the way across the circle. So in this problem, you have a small apple pie with a diameter of 8 inches, and a large cherry pie has a radius of 5 inches. And what we want to know is how much larger is the large pie. And because we're talking about that, that means we want to know area. So again, pause the video so that you can solve the problem, do a sketch. And here's our solution. So with my smaller pie here, I know that my diameter is 8. That means my radius is 4. So its area is 16 pi square inches. And then over here for this pie, its radius was 5, so its area is 25 pi. Now I'm leaving my answers in terms of pi. It's just going to make it a little bit easier for me to solve the problem, and I have to do less calculations on my calculator. So if I want to know how much bigger this large pie is than this small one, I just take I'm finding a ratio here. So I'm taking my area of the large pie, the 25 pi, and dividing it by the area of the small pie, 16 pi. You end up getting 1.5625. So we would just say it's about 1.5 times larger, or 50% larger than the small pie. And here's our second example. If the area of the circle below, not at the right, is 256 pi meters, so that's its whole area, and we know that from the picture because the circle is shaded in and it says 256 pi. It's not talking about circumference or any other measure, and the units are squared. So if we know that, what is the circumference of the circle? Pause the video to do the work. And here's our solution. If the area is 256 pi square meters, and we know that the formula for area of a circle is pi r squared, we take that 256 and we substitute it in for the area, and then you can divide both sides by pi, and so the radius squared is 256. Taking the square root of that will give you 16 for the radius. And then to find the circumference, you can use 2 pi r, or diameter times pi is 32, and so the circumference is 32 pi meters. Remember, those units are just the units, not squared, because we're just talking about distance. For example, 3, 4, and 5, I want you to look at the circles and see if you can figure out what fraction of the circle is AB of circle T. So think about what clues you're given here with the angle measures. For number 4, what fraction of the circle is arc CED? So we're looking at that whole arc. And then we want to know EF. We're talking about this minor arc EF because it does not include point A there. So pause the video, write down those fractions. And our solutions are, this is 90 degrees for the central angle, so 90 out of 360 is 1/4, so it's 1/4 of the circle. For number 4, that's half of our circle. It's 180 degrees out of 360. And then for number 5, it's 120 degrees out of 360, which is 1/3 of the circle. Now that's very important because we're going to use that information to help us find arc length. And all arc length is it's part of the circumference. So on page 350 in your book, you're going to pause the video in just a minute and you're going to go through this investigation, work out each one of the steps. Some of these first 2 circles are like the ones we just looked at. This one here, though, this last one, I want you to notice that's 140 degrees, not 120. So that's going to look a little bit different. And it gives you some measures for the radii for each circle. So you'll find the circumference, and then you're going to find the length of the arc for each one. So again, pause the video, and you're going to do this for all 3 of these circles. And then once you've done that, see if you can write a conjecture for arc length before you unpause the video to find the solution. So here we go. Our first circle, the circumference was 24 pi because the radius was 12, so all the way across was 24. And because this is 90 degrees, that means it's 1/4 of the circle. So I'm just doing 1/4 of 24 pi, which gives me 6 pi meters. So that's my answer for the first one. For the second one, the circumference is 8 pi. My diameter going all the way across is 8. And that's half of my circle when I'm looking at arc CED. So half of 8 pi is 4 pi. So my answer here is 4 pi. And for my last circle, circle P, I'm talking about this arc right here that's 140 degrees. This one doesn't give us a nice fraction like what we had before. So when you take 140 out of 360, reduce that, 14 over 36, divide by 2, what you get is 7/18. The circumference is 72 pi, double that 36, and then 7/18 times 72 pi will give you 6 pi feet for that. And then when we look at our conjecture, all we're doing to find arc length is we're taking the circumference and we're multiplying that by that central angle divided by 360, just to try to get that fraction. It's much easier if we reduce the fraction when we can, but you don't have to. And here's example 6. If the radius of the circle is 24 centimeters and the measure of angle BTA is 60 degrees, what is the length of arc AB? This is what we want to know. Pause the video, draw a sketch, and work on the problem. And when you're finished, unpause the video to reveal the solution. So if I know that this angle right here, this inscribed angle, BTA, is 60 degrees, then I know that this arc is 120 because 60 times 2 is 120. We know that that arc of an inscribed angle is twice that angle. It also told me that the radius was 24. So to find the circumference of the whole circle, I double the 24, and that's how I get the 48. So the circumference is 48 pi. And then 120 out of 360 is 1/3. And so 48 pi times 1/3 will give you 16 pi centimeters. Let's look at example 7. If the length of major arc ROT is 116 pi meters, what is the radius of the circle? And we also know that this minor arc here is marked as 120 degrees. Pause the video, draw a sketch, and do all of your work, and then come back to unpause the video to check your answer. So when I start this problem, I know that I'm talking about this major arc right here of ROT, and that is 116 pi meters. Now this 120, I already know 120 out of 360 is 1/3. And so that means that major arc ROT is 2/3 of the circle. So if I do 2/3 of my circumference is equal to 116 pi. And the way that I solved that problem or solve that with a fraction on it is by multiplying by the reciprocal. So that 2/3 multiplied by 3/2, and that just, those reduce and give me 1. And then I have to do the same thing to the other side of my equation. So 116 pi times 3/2. You can do the 116 times 3 divided by 2, and then you have times pi. You end up with 174 pi. For the circumference, that means that the diameter is 174, and to get the radius, you divide by 2, and you get 87 meters. And our last question for your exit slip today, you have a circle here, and the radius is marked as an R. It tells you the circumference is 18 centimeters, and I'd like for you to find the area. Again, don't just jump right into the homework now. Do the exit slip to see what you know. Pause the video and come back to check your work. And here's the solution. The circumference is 18 pi, so that means the diameter is 18. The radius is 9. And to find the area, you do 9 squared times pi, you get 81 pi square centimeters. For your homework tonight, or today, please try page 451, numbers 1 through 10 and number 12, and then page 351, numbers 1 through 9. I don't care which one you do first. When we went through the lesson, the first part of the lesson was the page 451. The second part of the lesson was the page 351 that started with that investigation. So that's why they're listed that way. So hope everybody is doing well. We will have a video chat on Tuesday, same day as this assignment, from 9:30 to 10. And then there's also another one scheduled on Thursday from 1 to 1:30. So if you have questions about this assignment, about the lesson, any of that stuff, please plan to attend at least one of those, if not both. And again, I hope everybody's doing well. I miss seeing all of you all.